is an associate professor at CSE department in IT Patna. He has more than 16 plus years teaching and research experience. He has guided 10 PhD, 33 MTech, and 107 BTech projects. Currently, 20 PhD scholars are working under him. His research domains are machine learning, data networks, and security. He has published 26 journal papers in SCI Scopus and 89 research papers in international conferences. He is a senior member of IEEE and ACM. He is a fellow member of Institution of Engineers India. He has also written 2 books and edited 6 books of international publishers. Sir, it's an honorable moment for Institute to have your prestigious presence in today's event. We are truly honored by your deeds. I hereby request Dr. MP Singh sir to enlighten our minds with his expert talk. Sir, please welcome.
Thank you, Dr. Dilip, and thanks that you have given me this opportunity to discuss some research content related to machine learning in healthcare system. So thank you very much. Now I will share my slide first. So my slide is visible to all of you?
Yes, sir. Yes, sir. Visual, sir.
Okay. Thank you. So in this session, I'm going to talk the one research topic on which I along with my PhD student has worked upon. That is multi-scale feature extraction for malignancy detection in lung cancer. So to understand this work, it's a very simple work, but it gives us a very good result. So we are excited on the result also. In order to understand, I have planned my presentation in this fashion. So few minutes I will take to make you understand that why do we need to have the machine learning concept on the lung cancer. So sometimes we will spend on understanding the lung cancer and the need of the CT scan as a data set and the need of the CAD system. Specifically when we have the very good radiologists in our India, maybe the worldwide, the very good experts, means the cancer doctors, but still why do we need the CAD system? So as a total to understand this, some of the basic features, basic terminology that we need to understand completely. And after understanding that, I will show you the framework that we have thought of, the result of that model that we have proposed, and the certain limitations that may allow some of you to work in future. So if you look at the data, in India, 2018, 63,475 people died just because of the lung cancer. And ICMR, Indian Council of Medical Research, they says that the 27.1% new cancer cases will be because of the tobacco use. Oftenly we used to see the ad and all, but this has a very serious concern of the medical domain. As we all know that if any kind of the cancer, not only the lung cancer, if it is not been detected at the earliest stage, then it becomes very difficult to save the life of the human being. And another surprising fact is only 12.5% people are coming for the treatment at the earliest stage. That means these number of people only can save their life. So what is all about the lung cancer? It is nothing but the irregular, unrestrained growth of the some cells in the lung tissues. The survival rate of the patient suffering from the lung cancer is lower than the colon, breast, prostate cancer collectively. So it seems that this lung cancer is very serious and becomes the common also nowadays. So the reason for that, the 85% people, those who are taking tobacco, because of air pollution, 10 to 15%, radioactive gas, polluted drinking water containing high level of arsenic materials, especially in Jharkhand and all, if you look at, there are many districts, namely Simbhum, West and East Simbhum, their water is having the very high level of the arsenic and the some portion of the Gaya also. So this is these are the some reasons to have the lung cancer. And the earliest stage symptoms could be the blood in coughing, the harsh coughing, pneumonia, chest pain, unexpected loss in weight, appetite loss, fatigue, hoarse voice, wheezing, so and so. Now here if you look at this portion, if you'll see in this figure, if you'll see, this looks like some nodule, the lung nodule. In shape and size, it will be basically like a coin, but in size could be 3 centimeter or 1.2 inches in diameter or less. So they need to be at least 1 cm in size before they can be seen in the chest X-ray. This point is very important to understand. Why do we need the CT scan for the lung cancer to have the better accuracy and all instead of the X-ray? So at least 1 centimeter size, if it is having, means the lung nodule size is 1 centimeter, then only that can be detected in X-ray. And this size is a bigger size. That means that this nodule is not in the benign state, it may be at the malignant stage. So we prefer to use the CT scan to get the more fine detail images and can be detected. Even the size is as small as 1 to 2 millimeter. Whereas in the X-ray, the size, if it is in 1 cm, then only that can be detected in the X-ray. So that is the importance that why we are using CT scan as a data set for our model. This figure, if you look at here, the figure A and C, the pulmonary nodule, this portion and this portion. These two are completely different if you'll see in the 3D image of the same. So you look at this portion and here you look at this portion. So this is nodule which has the irregular shape, unrested stain. This portion may be the malignant, but whereas here, so very means you can say it at the earliest stage, which can be treated as a benign state. Now, in case of the lung nodules, the masses of tissues basically vary in size from 2 to 30 mm. So two kinds of the nodules, the benign and the malignant. If we are at this stage, there is a very high probability to get a cure. Whereas if we are in this, the less chances. So benign nodule size will be smaller than the 6 mm, and the shape, it will be the regular, edges will be a smoother and the color will be the even color. It's an important one to understand. And if the nodule is benign, then it will not spread the other parts of the body. And it remains in the same condition for next 2 years. Whereas in the malignant, the shape and size changes. It's irregular, lobulated, spiculated margin, and it doubles in size after every 4 months. So some of the pictures, if you look at, these are the malignant, you see the shape and sizes, and these are the benign nodules, just see the shape and size. So if we are, and our problem is to what? To detect whether the lung nodules are belonging to benign or malignant. Once it is being classified as a benign and malignant, the further treatments can be done. Now, the very few minutes, maybe 1 minute, to understand why the CT scan, the chest computer tomography scan, devised by Alan M. Krockmack and Godfrey and Hansfeld in 1972. And what happens in the CT scan, there is an X-ray tube which rotates at the different angle, which induce the X-ray photon into patients, which flows in their body. And that photons will be captured by the detector. And by using the various algorithm, it will reconstruct the image digitally. This is the basic fundamental concept of the CT scan. How do we get the CT scan? Just because of this. And by using the different algorithms, the same, we can construct the 3D image in the CT. Okay. In CT scan, now we have the very good CT scan just because of advancement in the technology has reduced the dose of the radiation. This is the concern. The radiologist normally tells you that don't get the exposed of your body for the very frequently for radiation. Even in the X-ray also, for maybe the 10 to 15 years, they will not suggest you to go for X-ray less than the 6 months. Just because of this radiation affects our body here. So this radiation reduces in case of CT scan 70 to 80%. And it takes in time 1 to 2 seconds or maximum the 30 seconds to complete the scanning process. It is fast, painless, cost-effective imaging tool. And moreover, no radiation remains in the body after the scan. It's a good part of the CT scan. Okay. Now we have to understand the CAD system. I was telling you that we have very good radiologists, very good doctors. Then why do we need to have the CAD system? So the one reason is not prominent, but one reason is the 10 minutes time is required, minimum 10 minutes time to require to inspect the images of the CT scans for the radiologist, number one. Number two, as per the proof that the human mind cannot keep the more images for more time, and it may not be possible correctly to correlate the different images also. Okay, so because of this, you will see this data where overall error rate is reported 7.6% for the every 53 patients. This is very high rate. Among 53 patients, the radiologist or doctors may not be able to understand correctly by looking the CT scans manually. And this is the one reason that we need to have the one computer-aided diagnostic systems which may try to reduce this error rate further. Okay. Now, these are the some basic steps of the any computer-aided diagnosis systems. The very first step is the data acquisition. You all may be knowing this. So here in our case, we are having the data bit set in terms of the CT scans. We will see in detail. Now, whatever the data you have, the data may require the pre-processing steps. In this case, if you look at the size of the CT scan images will be very large, but our intention is to be very focused area in that image. So in that case, can we think of reducing the shape and size and so that the less computations time will require? And after pre-processing, we are doing the segmentation, means only those portions which is required for the diagnosis will be segmented. Now, once the lung nodule segmentation has been done, you can have the process regarding the lung nodule detection. Means after segmentation, whatever the images you are having, let's say here this image, this image, this image, this and this. This all image may not be the nodule, the lung nodules. Some of them maybe there are some other tissues, some other nerves, and so and so. So we have to correctly detect the nodule first. And that can be done with the help of by reducing the false positive. False positive means the some images may looks like a nodule, but it is not actually nodules. Maybe there's some other tissue and your system is detecting as a nodule. So that is basically the false positive. So we want to reduce this false positive rate so that we can get the better accuracy of the computer-aided diagnosis system. And once the nodule is being detected, now the next step is what? To do the classification either as a benign or the malignant. So this is the basic steps of the any computer-aided diagnosis system. Now we will try to understand the new framework for multi-scale CNN-based convolution neural network malignancy classification of pulmonary lung nodules. So try to understand the some basic steps, then we'll see the architecture. So main purpose of this work is what? To perform the binary classification of pulmonary nodule using the CT images. In this work, we are proposing the multi-scale of size 64 by 64, 32 by 32, 16 by 16 convolution neural network architecture for benign and malignant nodules classification. In the proposed framework, we are using the transfer learning approach. That means the CNN which has learned the some features by using this input that you need not to learn again. So we are transferring whatever we have learned from this scale can be transferred directly to this CNN which is using 32 by 32 and so on. 32 to 32 we can transfer the knowledge whatever we have learned. So that means what? The whatever we are learning at this stage will not be wasted. That learning will be transferred at this so and so to preserve the learned features using multiple filters with the different size. We will understand why do we use the multiple filters. Now, for the experimental work, we have used the open data set, freely available, LIDC, IDRA, and the proposed work has achieved the 93.88% accuracy, 93.36 sensitivity, and 93.26 specificity. Now, the data set that we are using. So in the data set, we are using CT scan. So normally CT scan is having the size of 512 into 512 in the format DCM. This is digital imaging and communication for communication in medicine. This we are converting into the PNG format, the portable network graphics format, just because of to reduce the complexity, the computing complexity. And after conversions, we are doing the segmentation, means only the portion which is required for the further diagnosis. So segment the lung, parenchyma. And after that, we are extracting the rectangular region of the lung nodules. Then we are classifying it. And after that, we are building the training, validating the test, and the data augmentation we are doing for the training. Now, in this work, we have basically used the 1012 chest CT scan for this study, where depending on size of the diameter of nodules, like nodules greater than 3 mm, nodules less than 3 mm, non-nodules greater than equal to 3 mm. These three sizes we have categorized for our further study. So, what we are saying in the data set pre-processing, since we are using the supervised learning here, so each data set or each scan is being supported by the XML file, which gives you the complete detail, especially the malignancy score, which is ranging from 0 to 5. And that score is being given by the 4 different radiologists. So what we are doing, we are calculating the mean value of all 4 to get the final malignancy score. And these all will be using during the training. So nodules with mean malignancy level equal to 3, we have removed because, what is the reason? Because this is the non-nodules. So we are only interested in the nodules. So finally, we get the 829 malignant nodules and 1262 benign nodules. Okay, for the after doing the data process. Now, the very first is what is the convolution here. So with this figure, you will understand that it's like you can consider this is the function f, and this you consider as a function g, which is also known as filter or the kernel. The size of this filter and kernel will be certainly smaller than the size of this. This is your like input image. So what we are doing, we are rolling over this function to get the new feature. This is what, and this function, the rolling over the function g over the function g, we call it as the convolution operation. It's a mathematical operation. And that's why the name is the convolution neural. Okay. Now, to understand in much better way, I have taken the one example. If you have used any graphic package like Photoshop or Inkspace or GIMP, you must have used the many kernels, the many filters. Some of them are like the blur. Means if you are having any original image, you can use this blur to get the different features. Sharpen, the edge detection. These are the different filters that we have already used. If you are using the Photoshop or Inkscape, and maybe the in the Word also we have these filters. The MS Paint is also having the some of the filters. It works like a filter. I am just giving the analogy to make you understand that what is the filter meaning is. So let's say this Android we want to detect. So here we are using the 2 filters to find the horizontal lines and to find the vertical lines. Now, this is the original image. This matrix representing your original image. In this image, we are having this kernel. This is the kernel that we have, or the filter that we are saying. So the filters for the edge detection, we are using the Sobel filter. And this is nothing but this like a one function f and this like a function g. we are multiplying f and g, and whatever the value we are getting, that value we are summing up and keeping at the middle of that cell here. If you are having this scanning here initially, so this will be the center portion of this image. So after doing this convolution, whatever the results we are getting, we are placing at the center. And this process will be repeated one by one. Now, this function g, will be rolled over this portion. Means you leave the first column, then you start for the second column. Next time, start from the third column, and so on. So, as we are scanning from beginning from this top corner to this end, completely this layer, and finally we will be getting the features map, something like this. But one problem is what, if you look at this portion, this is what we are getting the feature map. Means we have extracted the features by using this convolution. In this portion remains blank. You look at this. This portion will remain blank. Reason is what? We are reducing the size by using this convolution. So what you can do, you can avoid this situation by padding, or more commonly we are saying the zero padding. How it will work? It will work something like this. Look at this. The same image, that this first row, this column, this has been padded with the 0. So now we are getting this resulting where there is no blank space. Okay. So in that way, the process of convolution we understood. So by applying the filter on the original image, we are getting all the lines which is shown as a horizontal. You look at this. After applying the horizontal filters, we get this, all the horizontal lines. All the vertical lines, you look at this, all these vertical lines we are getting after applying the another filters, we call it as the vertical filters. And if you combine these two, you will able to detect that this image is nothing but the Android image. So this is what we do. Same thing like here. This is the original image. If we are applying this filter, we'll get the blur image of the same. We get the another filter, you apply the another filter, we get the another image. If we are able to only detect the edges, then we are applying this filter to get the image of this original image. Okay, so we are able to. So in the real-time scenario also, we need to apply the different filters to fetch the different features, and then only we will be able to detect correctly. You look at this. Red color, it is showing the one filter we have applied. This is showing the, you just look at this here, this portion, this line portion. In the green, it is just a reverse one. So we are getting the different features made if we are applying the different filters. And these maps will help you to diagnose the further correctly. Now let's look at this. Let's say this original image we have, and if we are applying some low level filters, then the certain image you will be, means it will fetch some features, but you won't be able to understand exactly what is this. So we are applying let's say another filter. So somewhat we are getting some better understanding. The high level features, if you are able to get by applying the another filter, so you can see this figure. You look at this figure. Let me change the color. You look at this figure. You look at this. These are the, probably it looks like the tire of this image, or this figure maybe probably this. Okay, so by applying the different filters, we are able to get the different features which will help us to detect or classify the images correctly. So in the same way, at the particular convolution layer, we have applied the different filters to get the malignant or nodule size. nodule shape and size. So these nodules, it looks like that malignant. Some another layer, for example, I have written here the third convolution layer, here I have written the fourth convolution layer. We are getting the much better clarity, much better information about the shape and size of the nodules, which may able to detect correctly as either benign or malignant. Another concept that we are using here is the max pull. It's a very simple method. The feature map, this is feature map. On this, whatever the maximum value you have, that we are placing at this. So this operation we call it as the max pull. So what it does, it basically fetches the maximum value from the set of the same number of the feature maps. And what is the benefit out of this? It reduces the size of the feature maps, but it captures all the features. Okay. Now, since we are using the neural network, certainly we have to think about some activation function. So in our case, we are using the leaky ReLU activation function. What it does, the activation function in this, we have the sinusoidal 10H and the, in fact, the ReLU activation function. Activation function, you all understand that when the neuron will fire, when the neuron will be activated, that we decide based on this activation function. Here, if the x value is greater than 0, means that this portion it will be at 0. And if it is less than 0, then these functions will have 0.01x. That means even though the x value is 0, it gives you the certain gradient flow during the training. Otherwise, if you are using the ReLU, in case of x greater than 0, you look at this value, this x and y. If the x value is greater than 0, then it will be this, and if it is less than 0, it will be this. So this person said that if any value which is less than x0, this your neuron will not fire. This will not add any information during the training. So instead of using the ReLU, we are using leaky ReLU. And finally, once it is being done, this all process that we have done, we are giving to our input to the dense layer. So dense layer means what? That each neurons are connected to the every other neurons. So whatever we have got our output from the convolution layer, that will be flattened. So first it will be flattened. So it's like a 4, 0, 9, then 6, 3, 7, and the size of this will be very equal size of the layers, the number of neurons in the dense layers. And after dense layer, now you have to decide in your architecture how many dense layers we will apply. We will see in our case how many we have used. But after the dense layer, from the output, since our work is based on the binary classification, means only two classes we have, either malignant or benign. So output layers will have the two. So this is, but now the question is, after doing the certain process, certainly there will be the error at the end. So we need to reduce this error. For that, we are using the sparse categorically cross entropy loss to adjust the model weight during the training. And this will help you to get the less error, certainly the better result. Okay. Now, in the dense layer, we are using the softmax activation function, which works something like this. What it does is, whatever the neural network layers you have, it will try to assign some probability to the each. Okay, and this is the equation of the softmax. That means we are saying that as per this figure, the 77.5% probability that we have that given image is dot. 11.6% the probability we are saying the image is cat, and so on. So the softmax is what it tries to provide the probability to each possible outcomes. and we consider the probability which is having the height, okay, as a classification. Now, first you look at this, the proposed architecture. In this proposed architecture, we will see the three different inputs we have, because the multi-scales we are using it. So 64 into 64, 32 into 32, 16 into 16 images we have. And these three layers are not working parallelly. These all are in sequence. So first you understand this first, and then we will see the next. Here we are using the 4 convolution layer: convolution 1, convolution 2, convolution 3, convolution 4. Because we are into business of the very serious business specific to the lung cancer. So we don't want to miss any features. While applying the filters or kernels, by applying the different filters, different kernels, we want to fetch the different features of the original image, so that it will predict correctly or try to enhance the accuracy correctly. So in this convolution layer, after each convolution layer, actually input, CT image input, we had the 512, which was converted into the PNG during the data processing. So in this model, the first model takes the 64 is to 64 pixels. The second, 32 is to 32. Third is 16 into 16. And first layer, it uses the filter of size 5 is to 5 to perform the convolution operation on the input image, which will generate the 64 output feature. Whereas the second, third, and the fourth convolution layer uses this size of the filter: 3 is to 3, 5 is to 5, 3 is to 3. And after each convolution layer, as you can see in the figure, after each convolution layer, we are using the activation function, the leaky rate. Okay. Once it is being done, then finally we are, you see this, after the fourth convolution layer and this activation function, we are using the max pooling. Now, we are not going to discuss that this term, because we have already understood that what is the leaky ReLU, what is the max pooling and all. And once the max pooling is being done, then whatever the size of image is there, that we are performing the flattening. We have understood the meaning of the flattening. This is the flattening. This size, this matrix will be flattened, something like this. Okay. Now, after this max pooling, what it does, we have already understood, this reduces the spatial resolution, which will help in learning and the more complex features from the input. Once it is being done, we are using, in our architecture, we are using the 2 dense layer. You can have the 1, you can have the 3. You have to decide these hyperparameters. Now, this flattened output features maps are then passed to dense layer of the 512 neurons. The first dense layer will have the 512 neurons. And again, after this, you look at this dense layer. And after this dense layer, we are again using the activation function, because the output of this first dense layer, we have to pass to the dense layer 2. But when the neurons will be fired, for that we are using this activation function. Sorry. Okay. Now, after the second, which is basically the second dense layer, fully connected layer, we are normalizing using the softmax. We have understood what is the softmax. Okay. So many times it is being observed during the experiment that the fully connected layers often leads to the overfitting in the machine. This is a very typical problem in the machine learning during the training. Your training may be the overfitted or maybe the underfitted. But in this case, whenever we have the fully connected layers, possibly our model will be suffering from the overfitting. So this overfitting problems we are resolving by using the dropout, and we are using the 50% dropout. Dropout means the output of the one dense layer, all the outputs will not be connected to the as a input for the second dense layer. Okay, and at the end we are using the sparse categorically cross entropy loss. Means after this you will be getting the sum, means your model, this model will classify the input either as a benign or malignant. But here could be the some error. So we need to pass this error so that we can reduce or we can increase the accuracy of the classification at this point. For that we are using this cross entropy, the sparse cross entropy to means find out how much we have to adjust the weight of the neuron so that I will get the better result. So this, once it is being done for this model 64 by 64 input, now it is turn of the 32 by 32, which is our the second model. Now in this, if you look at whatever we have learned after passing or after doing the fine tuning of the neuron weight, finally we are satisfied with the result. So the whatever it is being learned, learning in terms of what? The weights of the neurons. That weight we are transferring to the next model of the same level, convolution. So whatever it is being learned at this stage, whatever we have learned at this stage, we are transferring. So what we are transferring basically, this is what the transfer learning concept. We are transferring the weights of the neurons, which is finely adjusted at this level, at this point. Okay, so that weight we are transferring to this level. Now this convolution layer, whatever it has learned, it is transferring to the respective layer of the second model. Here again this. So we are using the concept of the transfer learning, and that is being done by transferring the weights of the neurons. And now at this 32 by 32 input image, the same thing, the whatever the in model 1 we are doing, means after each convolution layer we are applying the activation function, and after all the fourth convolution layer we are applying the max pull. One thing you might have observed that for this convolution layer, don't think that the same filters will be used. Different filters you might be using. So in our case also we have used the different filters to fetch all the features that are possible. After this we are doing the flatten, then supplying, passing to the dense one layer, then the activation function, then dense 2, then the max pulling, and then finally we are classifying, and by using the cross entropy we are adjusting the neurons to get the better result for the classification. Once it is being done, then we are transferring to the next model, which takes the input of the 16:16. Here the same, all the layers are same to this. That means the final output that we'll consider, which is here, means after the third model. Okay, so these all three layers we have used for the training purpose only, for the training purpose. But now the question is what? Let's say you want to test. So while doing the testing, you look at this, because our final outputs we will be getting from this third models only, means at this place. So to test this, we'll be using this model only. Model which takes the 16:16 input. Now we have, let's say you have some test images. Now we are giving to this, and now from the test image we are verifying whether our model has learned, means the training is complete or not. that we can verify from our test results. Okay, so the first you do the training, then after testing and validating, if you need to provide the certain, means you need to do the certain fine tuning in the existing training, that you can do the again start the training after doing the some fine tuning of the hyperparameters and so and so. Okay, so this takes a lot of time. Okay, depends on your the computational facility. Now, so the one question you might be wondering, why the multi-scale feature structure? Because it learns the different patterns in the images using the different filter sets. Number one. Okay, so different filter size can focus on context information of the candidate nodules in different scale image, and feature extracted from different string can complement each other. So the more effective features can be learned through the different scale images. And that is the reason that we have used the three different scale images. Okay. Now, this is very the well known to all of you. The same thing, the different evaluation matrices that we are using to evaluate our model, based on the accuracy, the sensitivity, specificity, precision, recall, and F1 score. Now here we have categorized the parameter as a true positive. That means the image, the nodule is actually malignant and your model has predicted as a malignant. That case we'll call it as the true positive. Similarly, if the nodules are benign and if your model has detected or predicted as a benign, we call it as the true negative. This positive negative sense, it is like that if we are suffering from the cancer, we call it as the test positive. And if you don't have the cancer, then you can say negative result. So in that sense, we have given this term. Now, if your model is predicting the malignant, but actually it is benign, so that case we have considered as a false positive. Falsely, we are saying the patient is suffering from the cancer. Similarly, if your model has predicted the benign model, but actually it is malignant, then that case we are considering as a false. Now we'll see. So in our result, our model, the 774 nodules were actually detected as malignant, right? And these many nodules were originally malignant also. So this case you can say the true positive. So our module has detected the 774 nodule as a malignant correctly. Our module has detected 1177 nodule as a benign, which is actually benign. So we consider this case as a true negative. We don't have the cancer, but correctly predicted. Whereas the 55 nodules were actually malignant, but our model has detected as a benign. And 85 benign nodules were predicted as a malignant. So these nodules which were actually malignant and classified as a benign, we call it as the false negative. Whereas our module has detected 85 benign nodule as a malignant, we are saying this is false positive. And we have drawn a curve, AUC curve, area under curve, based on sensitivity, the true positive rate, or one specificity, false positive rate, which covers this much area. Actually, if you look at this diagram, let's say to make you understand the AUC, You have the specificity and the sensitivity. And now, if we have the curve something like this, so concept is if this curve is growing in this direction, that means your model is more better. So let's say module 1, this curve has given. The another modules which gives this curve, the M2. One more module which gives these curves, M3. And ideal model could be what? It could be at the right angle. Okay. So in this case, the M3 model is giving the much more better result compared to M2 or M1. And that's why we are able to, we are drawing the AUC curve to understand the performance of the proposed model. Now look at this, the result of our model. Here, this is the actual level. Means during the training, we have given these many, this you consider 1 you consider as a malignant, 0 you consider as a benign. So this is benign and this is malignant. So the 774 malignant, actually it is malignant and your model has predicted as a malignant. So this we call it as the true positive. Actually, the 1177 were benign and your model has detected as a benign. So this is the true negative. But your model, this 55 patients or nodules is actually malignant, but your model has predicted as a benign. So this is the false negative. Same way, this is false positive. So to find out the accuracy, what you want to do? This TP plus TN divided by this plus this plus this plus this will give you the accuracy of your model. Here, if you look at, we are calculating the precision, recall, and F1 score. I hope you all are aware of these terms. Precision means how much your model is precisely giving the result. Recall means your model out of actual data, how many it is able to recall that. That means if you look at this here, actual malignant data is how many we have? The 774 plus 55. These are the total number of actual malignant. But out of this actual malignant, how many we are able to correctly detect? The 774. So the recall will be the 774 divided by this. So if you'll see, it will come nearly 93%. Similarly, the precision, how precisely we are able to detect whether it is benign or malignant. So in case of, let's say, the malignant, this is the you have predicted. So out of 774, how many predictions you have done for the malignancy? This many. But उसमें से आपने कितना perfectly किया? This. So this is the precision. Now F1 score is, let's say you have the two model M1 and M2. One is giving the good precision, another is giving the good recall. So which model you will consider for your benefit? So for that, it is very difficult to decide. One model is giving the good precision, one model is giving the good recall. In that case, we calculate the F1 score. F1 score takes the F1 score is what? 2 precision multiplied the recall divided by precision plus recall. So it takes the both parameter into account to give you the better understanding of your model performance. So here, the F1 score for the benign, it gives the 94% and here it is the 92%. Now, the model that we have just now gone through is compared with the state of art models, the existing model, somebody has done it. So if you look at our model is giving the accuracy 93.88 compared to this. sensitivity 93.36 compared to this. Okay. A specificity, if you look at, our model is giving 93.26, whereas this is giving the 96.2. Right? So, in that way, if you'll see, our model is trying to improve the some results in terms of accuracy of the sensitivity and the specificity. This helps us to redefine our model fund. Now, some of the limitation of this work is our proposed work is taking the input, the 2D image. But actually, the oncologist consider the 3D view of the CT image. So, we are currently working on the 3D images of the CT scan to get the much more better results. And in that, we are trying to include the scores of the attributes also. These scores were given by the radiologist. The range from, we have seen from 0 to 5, it is been given. So we want to consider these attributes while using the 3D CT scan to get the better result. So finally, what we are saying is our model is able to classify the benign and malignancy nodule. But as I told you that since this is based on the 2D, but actually it is worth to mention here that the 3D images will give you the much more better results. And currently we are working on that. Now you can note down this URL from where you can get this data set, the data set that we have used for this model. And now this is the references to that we have used for this work. Thank you. Thank you very much.
Participants, if you are having any question, you may ask from the side. Yes, Vishal, you have raised it. Just ask.
Good afternoon, sir.
Yeah, good afternoon.
Sir, I want to ask that model issue is very efficient and effective, but sir, as we know, everything comes up with own disadvantages and advantages. Sir, can you highlight some point shows its limitation and disadvantages
No,
that we must keep in
you.
mind?
Please come again. Your voice is not clear. Please come again.
Repeat once again, Vishal.
Okay, sir. Sir, I want to ask if there is any disadvantages of this model that we must keep in mind.
Actually, okay, I understood. Actually, while proposing, the first thing that I would like to say that whatever module that you are proposing, theoretically, the machine learning says that your model should be generic in nature. Generic in nature means what? Whatever the input that you are giving for the respective, let's say in our case, the lung nodule, we have used a very specific data set. Okay. But this model, if it is giving the same accuracy, same result for the different other data sets, then we can say that our model is the complete one, number one. Number two, it is nothing like a good and bad here. It is what? While doing the experiment, we have to set up the hyperparameters. For example, we need to decide what kind of filters that you will be using, right? Because the filters which basically finds out the features which is suitable to detect the malignant or benign nodules. If we are not choosing correct filters, then possibly your result will not be improved by just increasing the number of layers or the using the some other the functions. Okay, and second one is the whatever the error rate, because in first epoch that we have decided, and whatever the result you are getting, you may not be happy with the first epoch result. So you need to run the second epoch. But if you are running the second epoch with the same neuron weights, then you will not get any benefit out of it. So that weight has to be changed of the neurons And for that, you need to understand the error rate. Now, the question is the way we have used here the cross, the entropy functions to decide in what way that we have to change the neuron weights. So the many hyperparameters you have to fine tune during the experiment. You cannot say that with this I am getting the result and this will work the good for the everyone or for the every data set. So in our case, whatever the fine tuning that we have done, it was based on the particular data set. We are currently also running the same module for the different data set and trying to fine tune our model. This is not the final model. So the points that you need to take care is, one is the hyperparameters of your model. Another is activation function. Which activation function that we are using? Let's say instead of the leaky ReLU, if you are using the ReLU, you might be getting the bad result. Or if you are using the, let's say the sinusoidal activation function or 10H functions, that activation functions may not at all suitable for the you. So choosing this gives you the some flavor to do the experiment in order to decide the parameters of your model. And parallelly, it will decide the number of neurons for the each layers that we are going to use. Okay.
Okay,
Is
sir.
there
Thank you,
anyone?
sir.
Okay, anyone? No? Thank you, NP sir, for your valuable time. Your expert talk has provided us with invaluable insights about multi-scale CNN-based feature extraction for malignancy classification and detection of pulmonary lung models for lung cancer. You talked about lung cancer, CT scan, need for CAT systems. You informed us how CNN, where sugar filter was used for age detection, was used for binary classification of pulmonary nodules in CT images and achieved a wonderful accuracy of approximately 94%. You also saw how equation function, transfer learning, and why multi-scale feature extraction was used. You have also explained parameter which is used to evaluate of any algorithm, like accuracy, ROC, confusion matrix. You also saw, I'm sure our participants have attained a better understanding about all these topics. Thank you again, sir, for taking a valuable time to impart with your knowledge. Thank you, sir.
Thank you. Thank you very much for giving this opportunity.
Our next resource person has come online, Dr. Prakash Kumar Singh, Senior Data Scientist, IBM. Welcome, sir. Sir, are you listening me, sir? Is it audible?
Thank you,
Okay,
Dr.
sir.
Vivek
Thank
Kumar
you,
Joshi.
sir, for accepting my invitation. On behalf of our institute, I cordially welcome you, sir. Sir, we are honored to have with you us. Now I will introduce about our resource person. Dr. Prakash Kumar Singh has completed his PhD in Computer Science and Engineering from Birla Institute of Technology, Mr. Ranchi, Jharkhand in year 2021. He received his MTech degree in Information Technology from Rajiv Gandhi Pedagogy Viswavidyalaya, Bhopal in year 2006 and BTech degree from Uttar Pradesh Technical University, Lucknow in 2004. Dr. Prakash has around 15 years of experience, which include both academia as well as ID industry. Dr. Prakash is currently working as a senior data scientist with IBM Private Limited, Kolkata since 2016. Before joining IBM, he worked with Joba India Infotech Private Limited, Kolkata as NLP research lead and R System International Limited, Noida as senior software engineer. He also worked as a STEM professor at Galkutia University, Greater Noida and HMR Institute of Technology and Management, Delhi during the period between 2007 to 2015. Dr. Prakash has a research interest in the field of deep learning, machine learning, and natural language processing. He is experienced in cloud computing technology and has been using AWS, Google Cloud, and Azure Cloud for quite some time. His technology stack includes Hadoop, Spark, and Docker, computer, container, and DevOps technology. Sir, it's an honorable moment for our institute to have your prestigious moment in today's event. We are truly inspired by your deeds. I hereby request Dr. Prakash Kumar Singh to enlighten our minds with his expert talk. Sir, please welcome. You may proceed.
Thank you, Dr. Dilip sir. Thank you for your kind words.
Yes, sir.
And very good afternoon to all participants. So, so let me present my screen. And as Dr. Dilip Chobe introduced me as a data scientist working in IT industry, so you people are just feel free to talk. I mean, any practical scenarios which I mean we are doing on day by day basis in IT industry. So, as the topic itself is AI in health care industry, so my talk will be more around the business side, along with some topics with deep learning that we can use over there, right? So let me present my screen. Dilip sir, if you can see my screen, is
Yes, sir.
it
Yes, sir.
is
Clearly.
you can see it clearly or any
No, right now, no. Before that, we were able to see.
so you are
Yes,
able to see it,
yes,
right?
yes.
Okay, thank you. So thank you all once again. Let me start with this application of deep neural network in healthcare industry. My name is Prakash Kumar Singh, and I'm working as a data scientist. So the agenda of this today's topic, which I'm raising here, is that we will be discussing about the healthcare data and its present status of healthcare industry in India. We'll be briefly touching about all these things. Technological advancement to store and process this high volume of healthcare data, the basic introduction side of biological neural networks and its resemblance with artificial neural network, and then we will be talking in brief about the deep neural network and its uses in the healthcare industry. So so when we so today we have been gathered here for discussing about the AI in healthcare industry. So it's very much important to build a kind of background to start to talk about this healthcare data, right? So the large volume of personal health data are collected on a daily basis in places like public health centers and hospitals, and these rich source of data can be used to improve healthcare services. But the question still exists is where, how, and who can use these data. So basically, we are living in a a smart era where every device has been turned into a smart device which can capture the data, and the case is same with the healthcare data as well, right? So that's how we are capturing high volume of data on daily basis. So this is the present status of healthcare industry in India. Healthcare market as of latest report, as per latest report, is healthcare market in India is expected to reach US dollar through 372 billion by the end of year 2020. And this is basically driven by rising income, better health awareness, lifestyle, and disease, and increasing access to the insurance sector, right? And as of 2021, the Indian health sector is one of India's largest employer, and it employs almost 4.7 million people in healthcare industry, right? So almost the biggest employer is the healthcare industry in India as of 2021. So the economic survey of 2022, it says that India's public expenditure on healthcare stood around 2.1% of GDP in 2021 and 22. So this was the almost 2.1, exactly 2.1% of total GDP of India, which was actually costing in healthcare, right? And in the recent era when we were the globe, the entire world was suffering through COVID. This Bharat Biotech vaccine and Oxford AstraZeneca Covishield was manufactured by Indian healthcare industry, right? So all these are instrumental development in Indian side in healthcare industry. If we talk about the manpower side, the number of allopathic doctors registered with qualified medical doctor registered under the state medical councils are around 1.27 million. It was recorded in 2021, which is significantly higher than the previous year of 2010. Right, so we can see how the healthcare industry is growing day by day, and involving a lot of manpower, and doing significant work and achievement in its sector. So what about if the government is also supporting, doing any sort of ad or supporting this healthcare industry in India? So definitely, if you see the figure, almost 86,200 crore was allotted to the Ministry of Health and Family Welfare in the Union Budget of 2022 and 23. That is in the current financial year, and the Indian government is planning to introduce a credit incentive program of worth rupees 500 billion to boost the country's healthcare infrastructure. So as of now, the healthcare industry is something that we all are very much closely familiar with, right? Sooner or later, sometime in now and then, every time we had to visit hospitals, and we had to take assistance from doctor and any insurance companies. So we can very much pretty much closely correlate ourselves with the development happening in the healthcare industries, and the growth that it has seen over the last couple of decades. So we can realize, and the numbers here indicating towards that growth only. So Ayushman Bharat aims to provide health risk coverage through health insurance and improve access to the primary health care through the health and wellness center. So this is various schemes run by government of India to support healthcare industry, and to make it even more valuable for serving people of India. So there are more statistical data that you can see over these links given below. And now, Now we are talking about so this was the current status of the healthcare industry right now in India. The kind of support government is providing to the healthcare, to improving the healthcare infrastructure in India, in spite of the fact that there are several flaws we can easily see in various hospitals and insurance sectors. So, availability of health data in digital format is the crucial, a major thing because of which we are talking about this deep learning or AI part over the healthcare industry. So, information and communication technology has created a paradigm shift. The way a patient clinical data is captured, stored, used, and disseminated. There has been gradual shift from a paper-based record to electronic records, and those electronic records are in form of electronic health record, automated health records, computer-based patient records, and electronic medical record. So basically, you people can also correlate with this. Like whenever we visit to hospital in our old days, right? We simply visit the doctor, and then doctor prescribes some sort of medication, and then overall health record of a particular patient was not recorded or saved anywhere, right? Other than those piece of papers that usually the patient himself do not bother to keep in a safe way, right? So that was the problem this healthcare industry in India was facing earlier, because most of the work was on paper, and no record were found on the in the digital format. So the situation was completely different, and now due to this infrastructure growth and government support and awareness and education, lot of activities parallelly going on in healthcare industry, which causing these patient health related data to be stored digitally. So this is one major reason why we are talking about AI in healthcare data today. So, but what actually is missing even today is, you see, if you talk about US, if you go over a US open data site, you will see a government has provided open data over there, and you can easily find the healthcare data stored there. You can explore those data as well, and the reason behind having that kind of open data is just because 96% of the hospitals in US, this is the record captured in year 2018, when 96% of the hospitals were implemented EHR, that is electronic health record system, in their hospital. So basically, what EHR does is, whenever we visit to the hospital, it assign a particular patient ID to the patient, and all the diagnosis and reports and all the patient related data is captured in electronic format. Though this EHR is a kind of software that varies from one hospital to another hospital, but US is far ahead in standardizing the format in which they capture the healthcare record. Okay, and if we talk about Indian side, in India, healthcare system is lagging far behind in implementing this EHR, in spite of the government significant push. So India EHR have been implemented by some of the private hospital, like Max Hospital, or to name a few. Like if you go to AIMS as well, you will see, or Apollo as well, they will provide you the patient ID, and then all your health related record is digitally saved over there. And whenever you visit next time, probably the same patient ID the doctor can use to track your medical history, right? So this is, a few hospitals are, though this EHR and healthcare revolution has already been started in India, but the main challenge still exists that hospital need to take proactively participating in recording their patient related data in EHR systems, so that I mean patient data from his huge population of India can be recorded in a digital format, on which we can think about some sort of uh, AI model that can be built over that data. So this is the challenge that we are still facing, and alongside we are working in that direction as well. So mainly EHR system are mostly it becomes more significant when it comes to chronic disease, where a disease persistent for a longer period of time. For example, a BP problem or sugar problem or any cardiac problem, right? So this kind of problem, while diagnosis or providing any solution to these problems, requires some investigation over the historical data. So EHR is really very useful in dealing with these kind of disease. Now, so we talked about the digitalization of the healthcare data, and the progress that India is doing in this area, when the paper-based work is now slowly and gradually shifting towards electronic record keeping of the patient data. And then the second thing we would like to discuss about is the technological advancement that enabling us that enabled us leveraging this huge volume of healthcare data. So merely having this high volume of data, you cannot do with anything with those data unless you have this technological side advancement. So this evolution we have seen in recent couple of years, or maybe the 5 or 6 years. This evolution has been significantly seen, and especially the evolution in hardware side, where we have significantly increased the computational power of the computing machine. For example, if we talk about the processing capabilities of CPU, earlier we were used to, this laptop or computing machine were used to have a CPU machine, but nowadays these machines are equipped with a GPU, graphical processing unit, and the tensor processing unit as well. So allowing us to deal with or process massive amount of data on the machine. And the other hardware evolution is, of course, the storage capacity has been increased significantly. You can easily relate the hard drive size in going back 5 or 6 years, and now the size available in the market, right? Along with the technology side, where earlier we had HDD kind of hard disk, and now the storage devices mostly having SSD, a solid state device, which is significantly and much more faster than the old HDD technology, right? So this evolution we can see in this hardware side, particularly the machine or laptop or computer side. And the other evolution that we can easily see is in the way this huge volume of data are handled at industry level, right? So there also we have seen significant improvement or evolution in terms of distributed storage and distributed processing, distributed and parallel processing side, where we come up with the technology like Hadoop and Spark, that enables storing this huge volume of data, and then Spark technology help enable us to process those volume of data parallelly, so that we can get the information as quick as possible. So the parallel computation and distributed storage is a crucial playing a crucial role over here in analyzing this huge volume of data. So other than this, the cloud computing technologies as well, they have majorly contributed in this healthcare industry, or in analyzing the healthcare industry data, or for that matter, any big data. When we talk about these big data or healthcare industry data, uh, problem is that the data itself is not the structured one. Some of the data you can simply see in a text format. Some data you can see in the image format. So there are n number of way the data are stored. Sometimes some sounds files are also related to, sound files also store some sort of health related information, patient information, right? So there are various format of storing those whole healthcare data. So these technological advancement enable us to store these data and then process them. Cloud computing side, they are basically these cloud computing technologies basically enabling a hospital or any health sector organization, whether it is a clinical site or hospital or insurance site, to store their data, patient data, on different types of clouds available. They can store their data in a public cloud, or they can have their own private cloud, or if they want, they can have this mix up of both the public and private cloud, and can leverage the advantage of hybrid cloud, where they can they can own their data and allow the third parties to work on their data in hybrid cloud. So these are the technological advancement enabling processing of the this high volume healthcare data, especially in terms of storage and in terms of processing and computation. So the two things that we discuss about when we are talking about the deep learning side of this healthcare is about the data source of data being generated, and then once the data is generated, then we need some sort of storage, and we need some sort of processing capabilities to mine those data to get the maximum information out of these unstructured high volume data. Now, as we see in technological advancement side, the major cloud computing players in market are AWS, GCP, IBM Cloud, and Azure. And the kind of capabilities these cloud computing service providers provides us is with they provide us compute facility, the storage facility, and you can also use various machine learning, already trained machine learning model that you can make use of from these cloud service providers. Because in recent development we have seen, like if you people are working with the text data, you already might be familiar with fast AI, or what to wake model, or for that matter any model which requires significant amount of data, and which cannot be trained on a personal laptop. You see, this what to wake model was trained on the Google side, and it was trained on billions of Wikipedia text data to build that model. So once they train those model, or they come up with the algorithm which is trained on huge volume of data, they are simply made available in here in this as part of service in the cloud computing technology. So this is and then the data storage part is basically the one challenge we see in healthcare industry is because the hospitals are the owner of the data, right? And nowadays we are living in an era where data is more valuable than petrol, or for that matter any uh, monetary stuff. So the storage of these data are very very crucial. So the hospital, they can have, they are now having on-premise data storage. They are using this public cloud data storage, and they are also using hybrid cloud data storage, where all those electronic recorded data are moved from their legacy system to this cloud storage data. So one major advantage over here is, once your data is moved to the cloud storage, rather than your on-premise data, is then from that point onward, the data is available and accessible from across the globe, right? So you do not necessarily be physically present in a particular physical location in order to access those data. So this is the great advantage of pushing the data, healthcare data, on the cloud storage, so that if you want other other parties to involve and collaborate in doing further research on the data, you do not need to send the data to the third party or to the other party. Just the data is securely placed over cloud storage. The data, it can be accessed by from anywhere on the globe, and anybody can contribute and work with the data. So this is of course the major advantage of having the cloud storage. So 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 now I guess you got this answer of this question, why to discuss about deep learning in healthcare now. So we discussed about availability of data, we discussed about the advancement in technology sector, and we discussed about the probably we not discussed, but yeah, we will be discussing about the advancement in machine learning algorithm as well, especially in the deep neural network side, that provoking us to make use of full strength of deep learning capability in healthcare industry. So some of the application which we can see in deep neural network in healthcare are basically the deep learning or deep neural network can be leveraged in medical imaging, health monitoring, or visual assistance or chatbot, and so forth, right? I mean, there's n number of application. These are listed a few of them, but there are n number of application you can think of using deep learning in the healthcare data. In fact, wherever there is a tremendous volume of data, right, and the data volume is so much high that it cannot be explored manually, all so of course impossible. And even with the simple or traditional machine learning algorithm as well, this data exploration is not that much giving any insight. Then probably we can think of using a deep learning model in that data. So healthcare data of course fall into that category. One major application I can see here listed here is the document analysis model to extract text, table, and lines from. You see, the last point is the document analysis model. So we can use. I mean, this I would like to highlight here is you can use this deep learning model particularly. Apart from the other application, it can be used particularly in document analysis, building document analysis model, because uh, because as we just discussed that in spite of the fact that government side is pushing this much to move towards the digital record keeping of the healthcare data, still we are lagging behind, far behind. So we but of course many hospitals data is something like we cannot have over a period of 24 hours, 48 hours time, right? So it accumulate over a period of some some 10 years, 20 years, 30 years, and so on, right? So it cannot be accumulated fortnight, right? So so the one progress that we are doing is in this side where we are doing EHR. We are trying to implement EHR in all the hospitals, and the other progress that we can make alongside is building such kind of model where the existing paper-based health record can be digitalized or can be stored in a digital format. So document analysis model is something kind of that model which actually if you this is the kind of model which is trained on such billion of scanned document, and once the document is handwritten or handwritten medical prescription or patient record, all these documents can be scanned, and then the model can be trained to extract those handwritten prescription or health report of the patient from the paper to the electronic storage device in a digital format. So this is how the deep learning is helpful in building the digital record of the healthcare data. Now, now, now we have data. We are hoping that whatever data we have is as of now is sufficient to start work with and to get some insight out of those data. So in the data science field, the role of a data scientist in healthcare industry is when a data scientist work in healthcare industry, actually its role is not limited to simply that building a particular model out on a data set, right? Because the data science is mostly towards the business side of the healthcare industry, right? So business wanted to get maximum maximum monetary advantage, as well as it's all about the healthcare product that can be sell or that can be used to make financial or monetary benefits. So, so the role of data scientist in healthcare industry involves right from collecting or capturing the data from its original source and placing it to the destination data storage. This is one thing that a data scientist need to do. So the data capturing it, the data capturing can be done from the edge devices. It can be done from the hospital, various devices in hospital, or directly from the data stored in the hospital, their personal data storage system. So this is one task that definitely a data scientist need to do, to fetch the data from its original source and keep it in a standard format or in the other storage system from where it can leverage or start exploring. The other work is analyzing data scientist. The data is of course related to hospital. So what exactly the hospital want out of this data set is the another concern of the data scientist, and the kind of work data scientist involved with the data is pretty much co-aligned with the hospital's requirement. And then structuring and storing, at this point we already discussed. And then once the data is available here, then doing some sort of exploratory data analysis on those data, and transforming the data set into from one format into another format. And while doing so, the data scientists really make use of n number of tools to get all this work done. And then of course, then at the end it comes to build some sort of machine learning based model or deep learning based model. So before uh, building a model, there are, I mean, building a model is just, you can say, I mean, it requires a lot of thinking and a lot of mathematical aspect involved in building the machine learning model or deep learning model. And this is same, I mean, you can say, is the heart of this whole pipeline. But the other truth is that this part is, but I mean, very less in overall pipeline. So you can say 80% of the 80% of the effort a data scientist put in the fetching, in data fetching and extracting and then analyzing. So all these activities, data scientists are involved. And then finally they build, once the data is almost cleaned, and then seems like uh, the kind of balance and it analyze the distribution of the data. And after doing so many analysis, the time comes when a model can be built over that data. So that is the last stage. And once the model is built, probably it can be connected to some sort of dashboard for the end user, or some REST API can be exposed for the end user. So this is what a data scientist do. So now, so some of the advantage of this predictive modeling in healthcare industry is these are listed down over here. It help in management of predictive modeling. We are doing a predictive modeling. That means after building a particular model on the patient health data, we are actually trying to predict some sort of disease. So the disease prediction, it belongs to a particular patient, where the model see the historical health record of the patient, and then it predicts in near future what are the uh, what are the variation this particular patient is feeling, and then what cause it may be, or what chronic disease may come again to this patient. So it is a kind of predictive modeling, we can say. And then it also help efficiently monitor and analyzes demand of pharmaceutical logistic, because all the health hospitals are supported in the back end by the pharmaceutical industry. So all those logistics are needed, and with the intelligent monitoring and modeling, with this volume of data, supply of these logistic can be fulfilled to serve the people, right? As we seen, like when we were in COVID situation, all of a sudden the increase of various logistic all of a sudden increased significantly, and it so much increased that the government was almost unable to provide these. We were facing shortage of this sanitizer and face mask at a time, right? So with the help of predictive modeling, such crucial situations can be handled. And apart from this, it predicts the patient condition and suggests preventive measures. And then it provides faster documentation of the hospital data. It helps in efficiently utilizing doctors and other resources for the benefit of maximum number of patients, and it predicts the future medical crisis of a patient. So you can think you have all the record of all the data of all the hospitals. So when we are talking about healthcare data, it does not limiting itself. The data does not limit itself to the patient data itself, but also it include the other data like the beds, number of beds available in a particular hospital, or the medicines available in particular hospitals, ICU facilities available in the hospital. So all the resources whichever you can think of in a hospital, all these data can be recorded in a digital format, and then the predictive modeling can be applied over there, and you can think of this scenario where a particular patient is I mean overnight uh, some I mean all of a sudden if it's facing any heart attack or any severe such condition, then this predictive modeling solution should be able to in a particular geographical location, it should be able to indicate which hospital and which where the patient can be treated with high availability of the doctor and other resources. So this is the other important use of this deep learning in the healthcare industry data, right? So we already studied, we already saw that the resurgence of this deep learning in the past few years is just because the availability of this huge volume of data and the technological advancement. And now we will be seeing some basic concept behind the deep neural network. I thought to keep this section all pretty much basic level, because we anyhow we cannot cover in a period of 1 hour time. So as you know, the a deep neural network is basically the extended version of a neural network, artificial neural network. And the deep, the term deep means you may have multiple hidden layer in between the input and output layer, making it actually a deep neural network. So basically the artificial neural network is the basic building block of this deep neural network. And in turn, this artificial neural network is basically the resemblance of the biological neuron. You might have already gone through this kind of topic, but this is how the biological neurons looks like, sitting in brain and having dendrites and axon. Dendrite is the receiving end, and axon is the when where it released the data, right? So with the help of dendrite, it received the signals, and it processed the signal in the cell body, and then it passes the signal through the axon, and then ultimately the axon branches actually releases this signal to the next cell connected after this cell. So this is how the information flow from one neuron to another neuron. And the same concept is actually there in the artificial neural network. So this is how you can see how the neurons are connected, and the connection point is synapses, where actually the signal are passed from the previous neuron to the next neuron. And the similar concept is used in the artificial neural network. But before we actually, this deep learning and machine learning part is a pure mathematical one. So I mean, if someone is new, or someone is just starting this neural network or deep learning part, then some of the mathematical concept one should be very much familiar with. Or if you are not already familiar, then first, before jumping directly into neural network and deep learning, just start with building some basic concept surrounding this linear algebra, statistics, and differential calculus, and optimization and probability. So these are some mathematical terms, or surrounding mathematical concept that you should be very much be familiar with, so in order to understand the inner functionality of the neural network and deep neural network. So one should also be familiar with these mathematical terms like scalars, vectors, and matrices and tensors. So you all are very pretty much familiar with scalar, vectors, and matrices. And the tensors is basically when we are when we want train a deep learning model, or for that matter any machine learning model, the data should be in a structured format. So earlier the format might be anything, it can be stored in any format, but the moment we are feeding in the data in the neural network, a deep neural network, it should be transformed into a clean and structured format, and then only the neural network basically can take this data and process and work on that. So a matrix is going to be very crucial. I mean, the way you should be looking at the data is in a matrix format or tensor format. And matrix is basically your two-dimensional array, while a tensor can be of n number of dimensions. So you can have 1,000 dimensions, and then the information is just hidden in between those 1,000 dimensions. So you need to explore those dimensions in order to explore information from the data, right? So and especially when you are training a deep learning model on the text data, right? Particularly, then you will see this significantly high dimension with almost very less relationship among them. So the text data usually deal with 10,000, 50,000, or 20,000, even more dimensionality. So somehow our mind is very much limited. We cannot think beyond the 2D and 3D visualization. But you can think of 1,000 dimension data as a point sitting in a 1,000 dimensional coordinate system. So this is how you should be looking at the data, and this is how the artificial neural network looks like. So pretty much similar to that of biological neuron, where all these there are the input side and then the output side, and input is all these inputs are actually multiplied by weight term, and then they are being summed up together, and then some sort of activation function is applied on the sum, and then finally you are getting the output. So this is how artificial neural network works. And if you see this equation, I think this is pretty much small, or what. Yeah, you can see this the equation z is equal to w0 plus summation of I equal to 1 to n wi into xi. This is pretty much a linear equation, right? So up to this point where we have indicated a node with the summation symbol is pretty much talking about the talking about the linear relationship among the data. But we know the real life data, there is hardly a linear relationship when we are dealing with the complex, and that too with this huge high dimensionality data, right? So of course there is non-linearity exists, and that's the reason we add this activation function in the neural network to add the non-linearity in the neural network. And so a neural network basically comprises of four main components, which of course the input, weights, bias and threshold, and output. And when we say that we are training a neural network, we are building a neural network model. What it means is basically we are trying to learn. Because what you already have is basically the input you already have, right? And you corresponding to a particular input, you want some sort of output, and in between what this neural network is learning is the weight parameter, or you can say the weight matrix or the bias parameter, which a neural network learn while training the model. So the idea of training a neural network model is to learning these weight parameters. So if we see this equation, w0 summation of wi into xi, the whole idea is to learn this wi corresponding to each xi, where xi is the input for the neural network. So for each xi, I mean, it try to learn the best value for wi, and then we once it learn this best value for each xi, we say that okay, the model is trained enough to make a prediction, because in that case the model would be able to predict exactly what is expected. But in between there is a number of things that comes in the picture. So this is how the deep neural network looks like. Simply you still have input and output layer, and in between there are n number of hidden layers. And the idea of having this n number of hidden layers is sometimes the when you are dealing with the very high dimensionality data, right? Simply a two-dimensional data or simply one hidden layer or neural network is not sufficient to extract the feature that gives you the exact output, or in fact, or any output that is close to the expected output. So that's the reason we may have a multiple hidden layer over there, where one hidden layer try to extract one sort of feature, the other hidden layer work on that and try to extract some other hidden layer, right? Other hidden features. So having multiple hidden layers means you are further extracting some more hidden information from the input data. So now the active one. So as I said, this activation function basically introduces non-linearity, and there are uh, uh, the major role of this activation function, apart from adding this non-linearity in the neural network, is it whatever value you provide to the activation function, it basically squeezes down the value in between either 0 to 1 or -1 to 1, depending upon the kind of activation function you are using. So suppose if you are using a sigmoid function, we pretty much know that the sigmoid function output in the range between 0 to 1. So irrespective of the value you are providing, right? If you are providing 5, or you are providing 5,000, or you are providing 5 lakhs, in the output you will be getting in value in between 0 and 1. 0 to 1. So the output of sigmoid function, you can say, is scaled between 0 to 1, right? And somewhere when you are dealing with the probability of something, right? You wanted to assign some label to some image, and where you are dealing, then probably you see any value between 0 to 1, it resemble itself towards the probability of something, right? Something happening. So that's how the different activation function play a different role. But in most of the time, in hidden layer and input layer, we use this sigmoid tanh function and rectified linear unit. Of course, Licky Relu as well we used, or there are other activation functions as well, but these are the most common activation function we mainly used. The another function that we used mostly in output layer is the softmax function, which basically is used in case of multi-class classification, where whatever input you will be giving to the softmax function, basically it will be in output, it will be giving you the probability of each output, probability of assigning a particular label to each whatever is available in the outcome. So mainly it gives you the probability, multiple probability, you can say, probability for multiple items. So these are the activation functions you can see, and you can see the sigmoid function, the graph of sigmoid function, it's lying between 0 and 1, and then the tan h function, it's lying between -1 to 1, and then the ReLU function, its value, the equation and its derivative, and the value, you can easily see over here. In case of ReLU, whenever your value is less than 0, it will always be 0, and if the value is greater than 1, then the same value will be in the output. And along with the sigmoid, this activation function output, I have also shown here the derivative of those activation function. The other important reason, if you see the derivative of these activation functions, these are pretty much straightforward, right? You have equation of sigmoid function, and then the derivative is simply fx into 1 minus fx, right? So this is how these derivatives look like uh, when we are talking about the sigmoid function and then tenoid function, or even the ReLU function. So the basic idea is, because we have to implement these activation function, and the computer has to do this sort of computation, right? So of course the computer or the processing unit is not going to do those mathematical derivation for if it is engaged in doing derivation in a traditional way, it will take a, a, a long time, and then this whole meaning of training a deep learning model will lost somewhere, because if any software system is taking long huge time, then probably that's not a feasible solution at all. So the simplicity of this activation function and the derivatives is the main reason behind using these activation function in the deep learning in neural network. So the cost function. So basically the cost function, what it does is, you had some input, and then you got some weight parameter. Maybe these weight parameters are randomly initialized with initial 0 values, or you may have some algorithm like Glorot algorithm or Javier initialization, where it assigns some initial value to the initial weight parameters, and with this initial weight parameters and input, you predict the output. Now when you have predicted the output in first epoch, right, how the system will make sure that the whatever prediction the system is making is the correct prediction, right? So there should be some judge sitting over there in the output side, which tell, okay, you are wrong or you are right. And this cost function and loss function is exactly doing this. So whenever your model predicts some output, in the training phase, we understand that the model is provided with the input and output data. So this is the kind of supervised learning where the data is having this pair of input and output, and when we train, the model will be predicting the output, but at the same time we already have the output for that input, right? So that we can have a kind of comparison, whatever model is predicting is actually matching with our existing output or not. So this cost function pretty much do the same thing, and it compare the predicted output with the already existed output, and and then based on the difference, it figure out the error term in the model prediction. And when then you got the error term, then what to do with this error term, right? You have got the error term, your model predicted something, and it's showing that, okay, your prediction is this much erroneous, right? Then what next? The next step would be to repeat the process, and while repeating the process, we wanted to minimize the error term, right? So basically this problem becomes the optimization problem, where when we talk about optimization, we already know that when we are talking about profit, we wanted to maximize it, and when we are talking about the loss, we wanted to minimize it. So this is something something optimization problem. So that optimization we wanted to do, and while and how we do that kind of optimization is, we calculate the gradient of the error term with respect to each weight parameter. uh, we calculate the gradient of each weight parameter corresponding to all the weight parameters. So basically we calculate the partial derivative of the weight parameters, right, to update the weight value in the next iteration. And with the updated weight parameters, the model predict the next outcome. So because this time the weight parameters have been updated and the model is predicting something new outcome, we there is a cost function which actually compare the, I mean, existing output and with your predicted output, and this whole process keep on going unless your weight parameter is updated in such a way that the model prediction is almost close to the expected output. So this is how, and this cost function basically in terms of classification we say it a binary cross entropy, right? So this is the in the neural network we say this loss function. So when we are training the neural network, basically we are using a back propagation, following a back propagation approach, where we are back propagating in a back propagation model. We are actually back propagating the error terms. So whatever error we calculated, we figure out the derivative, right? And then we are sending those error terms back towards the starting layer of the deep neural network. So in while training the neural network, these becomes pretty much important, your initial weight parameters and the learning rate and the momentum, which basically determine how well your model will predict. And during this whole learning process, how many parameters the neural network learn? So this is you can simply calculate this the total number of weight parameter and bias parameter that the neural network learn or deep neural network learn in the process of training. So if you have n number of node in input and s number of node in output and o number of nodes in output, then probably you can use this formula to figure out the total number of weight parameters that the neural network updates in each iteration, right? And uh, when it comes to train the deep learning model on the real data, these weight parameters really become very huge. It may reach up to millions. So that means some millions of weight parameters are being adjusted in each epoch, and then all these weight parameters are not independent, because we are updating the weight parameter with respect to the other weight parameters value. So all these weight parameters are actually seen parallelly, being updated parallelly, and adjusted number of parameters and combinations and done to get the best values for those millions of weight parameters. And so this is your optimization algorithm we already discussed. So your and so once your model basically learn this optimum value for the weight parameters, you say that your model is trained. And when you save the model, basically MD5 in MD5 format practically. So basically you are actually trying to save this learned weight matrix, right? So what happened, you trained the model over a huge volume of data, and this training cannot be done, I mean, repeatedly, right? Because you are training your model on huge amount of data. It cannot be repeated again and again. So you are actually, once you figure out the best value for these weight parameters, you try to save those weight matrices in a file, and later on you can transport these weight matrices, and someone else can make use of the already trained weight parameters for making their prediction. So that's how we when we make use of a pre-trained model already which is already trained, basically we are making use of these weight matrices which is learned during the training period. Okay, so most frequently used deep neural network are basically this recurrent neural network and a convolutional neural network. We have seen, like recurrent neural network is mostly it works with the NLP problem where you are dealing with the text data, while the convolutional neural network, as MP sir was telling you in detail about, I mean, these convolutional neural network is significantly used uh, in image processing or computer vision. So there are a number of there are various type of deep neural network model like LSTM, bidirectional LSTM and GRU. So uh, uh, I don't think we have much time to discuss about, but yeah, I think um, we can close over here, and then you know, some of the tools that you can make use of in order to implement this deep learning model is you can use Keras, you can use TensorFlow, or you can use PyTorch to build your deep learning model. And uh, my suggestion would be in that direction. I mean, don't first you try to implement these deep learning model in using these tools, because these tools they have those libraries which support building a different function, like the activation functions. They have already implemented, so you do not need to write a function, define a function where it's going to calculate those activation function values, right? So all these small things are already available there in the library. You can make use of those library. But yeah, these tools actually provide you some beginner level capability. But when building a complex model, you need to understand at what point of time, at what position, what particular component of this tool you should be using at that moment, right? So as we said, that deep learning model involves n number of layers. So this is only you who will determine which particular component you will be using at a particular point of time by looking at the data input and output at that point in the model. So this is just a snippet I was thinking to discuss, but it's already. So I think you have any question you can ask.
Good afternoon, sir.
Yeah.
Sir,
Good afternoon.
how do you think that data scientists can help in the healthcare system? Because nowadays we see that most of the data scientists go into the IT industry. So how they can help in the Indian healthcare system?
See, data scientist. Uh, when it comes to data scientist, he is pretty much trained on using various tools and technology, right? He is the one who can suggest a healthcare industry that in what particular format the data can be stored, so that it can be consumed by any software application. So and how the data can be fetched from the edge devices or the or source of data to the industrial side, or to any to such storage site where the accessibility of data become feasible. So from architecture side till the implementation side, data scientist role majorly is a kind of architecture. If he can play a implementation role over there, that is also very good.
Thank you, sir.
Is there any more question by anyone? Yes. Okay. So thank you, Prakash sir, for your valuable time. Your expert talk has provided us with invaluable insights about applications of deep learning, deep neural network in healthcare. You talked about Indian healthcare systems and government programs to improve it by digitizing the systems. You also talked about the challenges related to it and how they can be overcome by using cloud computing technology like AWS, GCP, Azure. Then you also inform about basic concept of deep learning and how DNN can be used to medical imaging, health monitoring, document analysis model, cancer and tumor detection. You told us about the roles of a data scientist in healthcare sector. I'm sure that our participants have attained a better understanding about all these topics. Thank you again, sir, for taking your valuable time to impart us with your knowledge. Thank you, sir.
Thank you, Dr. Dilip Kumar sir, and thank you all the participants for listening with patience. And you can reach out to me at later point of time as well if you have any query. I would be responding over there. Thank you all.
Okay, sir. Thank you. A few minutes for next person is going to be come online.